In in this article, we'll discuss the basic idea behind an engine and then go into detail about how all the pieces fit together, what can go wrong, and how it increases performance. The purpose of a gasoline car engine is to convert gasoline into motion so that your car can move. Currently, the easiest way to create motion from gasoline is to burn the gasoline inside an engine. Therefore, a car engine is an internal combustion engine. Engine combustion takes place internally. Two things to note: there are different kinds of internal combustion engines. Diesel engines are one type and gas turbine engines are another. Each has its own advantages and disadvantages. Number two, there is also the external combustion engine. The steam engine is in old-fashioned trains and steamboats is the best example of an external combustion engine. The fuel, coal, wood, oil in a steam engine burns outside the engine to create steam, and the steam creates motion inside the engine. Internal combustion is a lot more efficient than external combustion engine, plus an internal combustion engine is a lot smaller. Internal combustion: the principle behind any reciprocating internal combustion engine. If you put a tiny amount of high energy density fuel like gasoline in a small enclosed space and ignite it, an incredible amount of energy is released in the form of expanding gas. You can use that energy for interesting purposes. For example, if you can create a cycle that allows you to set off explosions like this hundreds of times per minute, and if you can harness that energy in a useful way, what you have is the core of a car engine. Almost every car with a gasoline engine uses a four-stroke combustion cycle to convert gasoline into motion. The four-stroke approach is also known as the Otto cycle, in honor of Nicholas Otto, who invented it in 1867. The four strokes are illustrated in the animation. There are intake stroke, compression stroke, combustion stroke, exhaust stroke. How engine work: the piston is connected to the crankshaft by a connecting rod. As the crankshaft revolves, it has the effect of resetting the cannon. Here's what happens as the gas engine goes through the cycle. Number one, the piston starts at the top. The intake valve opens and the piston moves down to let the engine take in a cylinder full of air and gasoline. This is that intake stroke. Only the tiniest drop of gasoline needs to be mixed into the air for this to work. Number two, then the piston moves back up to compress the fuel or air mixture. Compression makes the explosion more powerful. Number three, when the piston reaches the top of its stroke, the spark plug emits a spark to ignite the gasoline. The gasoline charge in the cylinder explodes, driving the piston down. Number four, once the piston hits the bottom of its stroke, the exhaust valve opens and the exhaust leaves the cylinder go out the tailpipe. Now the engine is ready for the next cycle, so it intakes another charge of air and gas. In an engine, the linear motion of the pistons is converted into rotational motion by the crankshaft. The rotational motion is nice because we plan to rotate the car's wheels when with it anyway. Now let's look at all the parts that work together to make this happen, starting with uh, the cylinders. Basic engine parts. Inline, the cylinders are arranged in a line in a single bank. The core of the engine is the cylinder with the piston moving up and down inside the cylinder. Single cylinder engines are typical of most lawn mowers, but usually cars have more than one cylinder. 4, 6, and 8 cylinders are common. In a multi-cylinder engine, the cylinders usually are arranged in one of three ways: inline, B, or flat, also known as horizontally opposed or boxer, as shown in the figures to the left. So that inline four we mentioned at the beginning is an engine with four cylinders arranged in a line. Different configurations have different advantages and disadvantages in terms of smoothness, manufacturing cost, and shape characteristics. These advantages and disadvantages make them more suitable for certain vehicles. Figure 3. The cylinders are arranged in two banks set at an angle to one another. Figure 4. The cylinders are arranged in two banks on opposite sides of the engine. Let's look at some key engine parts in more detail. Spark plug. The spark plug supplies the spark that ignites the air or fuel mixture so that combustion can occur. The spark must happen at just the right moment for things to work properly. Bulbs. The intake and exhaust valves open at the proper time to let in air and fuel and to let out exhaust. Note that both valves are closed during compression and combustion so that the combustion chamber is sealed. Piston. The piston is a cylindrical piece of metal that moves up and down inside the cylinder. Piston rings. Piston rings provide a sliding seal between the outer heads of the piston and the inner heads of the cylinder. The rings serve two purposes: the prevent the fuel air mixture and exhaust in the combustion chamber from leaking into the sump during compression and combustion. They keep oil in the sump from leaking into the combustion area where it would be burned and lost. More cars that burn oil and have to have a quart added every 1000 miles are burning it because the engine is old and the rings no longer seal things properly. Many modern vehicles use more advanced materials for piston rings. That's one of the reasons why engines last longer and can go longer between oil changes. Connecting rod. The connecting rod connects the piston to the crankshaft. It can rotate at both ends so that its angle can change as the piston moves and the crankshaft rotates. Crankshaft. The crankshaft turns the pistons up and down motion into circular motion just like a crank on a jack in the box does. Sump. The sump surrounds the crankshaft. It contains some amount of oil which collects in the bottom of the sump, the oil pan.